Gauchery e tali, archivi sedimentari dall'ultimo massimo glaciale, LGM, per lo studio delle interazioni tra processi sedimentari governati dalla variabilità delle correnti di fondo e flussi gravitativi nel bacino di Gela, Stretto di Sicilia. Allora.
Buongiorno, mi senti?
Sì, perfettamente. È
Ah, ok, va
inquadrato.
bene. Allora, vedi la presentazione
No, vedo
adesso?
la scritta Go to Webinar, forse hai due monitor. Adesso
Sì,
sì, devi fare il solito discorso, display settings e fai la prima voce.
sì, second screen. È quella? Va bene?
Sì, perfetto.
Ah, ok, va bene. Vado a fare la presentazione in inglese as well. So I'm going to present one of my last paper. We just submitted to a research paper, marine geology, for my PhD, which is about the last archives, sedimentary archives of which talk about the interaction between submarine landslides and contra deposits in the Gela Basin, Strait of Sicily. Okay, so the Gela Basin is located in the central Mediterranean Sea between Malta and Sicily, and it's a 40 basin, which is constrained between the Maghrebian Fold and Stress Depth, which is a migrating stress wedge, which the last movement has been from the middle late Pleistocene, and in the north. So I don't know if you can see my point. So in the north and in the south, we have this rift system, extension on rift system, which has been started from the late Miocene to early Pliocene and continues through the Quaternary, and which forms this deep graben. So in the central area of the Strait of Sicily, and this also the Gela Basin is under the influence of this water masses exchange between the western and eastern Mediterranean Sea. Okay, and for example, this is few examples in the Strait of Sicily of contra deposits, which have been which is the result of this circulation in the Strait of Sicily. And the Gela Basin is also characterized by multiple massonite deposits, which has been studied in the north of the Gela Basin with the twin slides, and in the south of the Gela Basin as well. So the data we had access to were to have a high resolution swath bathymetry, which is around 20 meters resolution. So we can see here the limits of this 20 meters bathymetry resolution. And we had two piston cores which have been recovered in the 2005, but never been opened before my PhD. So which were new, and so which have been recovered, one in the lower part of the slope. So at the near this large massonite deposit, the SBS for South Gela Basin slide, and which is at 550 meters water depth, around 10 meters long, a piston core, and one on the upper slope, which is near the flank of the Gela drift slide, the GDS, which is around 8 meters long, piston core. So, and also we had access to multiple chirp seismic profiles taken everywhere in the Gela Basin, and for this we took only one piston core, one seismic profile, which got the two locations of this piston cores, and as well cross-cut this massonite deposit. So we can see clearly where we have these two massonite deposits and the location of the piston cores where we have zoom. So we can see the type of amplitude reflectors at this piston core cross-cut. So from low to high amplitudes, and in both we have different type of amplitude reflector cuts. And we also in this work put a date, thanks to an age model that I would present to you afterwards, that this reflector, which seems to be at the base of this Gela slide, and around the 17.5 kiloyears present, and another reflector, which is the last one cut by the South Gela Basin slide, around 16.8 kiloyears present. So the different objectives we had with this data and with what we already knew is to use multiple practices from the course to infer the occurrence already of different possibly gravity-driven and bottom currents transport sediments within the core. So to do that, we used different practices such as foraminifer assemblage, radiographic images of the sediment structures, grain size analysis, and different elemental ratios from geochemical, also the different plant debris which were present in the core. And afterwards, we try to distinguish with different methods the sediments which recorded the bottom currents from those who recorded downslope transport. And from this sediment which recorded the bottom currents, we try to reconstruct this paleoflow velocity over time, and afterwards to try to investigate how maybe these two large mass deposits, the condition which predispose to this emplacement of these two large mass deposits. So to do this, to try to identify this sediments transported by bottom currents, we use this practice such as foraminifer, because when they present homogeneous phase size, they tend to infer sorting. In the structures of the sediments, we have laminar, such as horizontal curves, or also the grading, which tend to help us to identify the sediments that have been reworked by bottom currents. So we can see, for example, two examples of the core which has been recovered on the lower slope. As well on the upper slope, we can see this on the grain size frequency and distribution. We can see this nicely bimodal distribution, which help us to identify the area where the sediments have been reworked by bottom currents. And also some different elemental ratios such as zirconium versus rubidium, also the terrigenous flux, because we know that when it's present pretty low, we tend to have more bottom currents sorted. And for downslope transport practices, we use also foraminifer, but more like when they've been reworked, mixed, or broken. For example, we have this example of Ilphidium crispum, which is typical of inner middle shaft environment. In the core we found, which was on the upper slope core. We have examples also, so which is called benthic from the shelf. We have also this typical type of lamination, but cross lamination and frame structures, erosional contact, which help us to identify the sediments which have been transported by gravity. Also the soluble silts, and when they tend to have a unimodal distribution, as you can see in the lower part of the core. And also the presence of plant debris that we found only in the deepest core, where when we made the analysis, we saw that they would come from more inner land, but after analysis, we found that most of them, all of them, were actually from inner middle shaft environment. And the vegetal remains, which were the plant debris we found, are all been located in this part of the core. So where we had this really high amplitude reflectors in the seismic as well. And so after identifying the different sediments which have been reworked by bottom currents, we try to reconstruct the flow velocity. So to do that, we used a method by Mike Cave and Andrew, which is a linear regression analysis. And so, for example, here we have a scatter plot of the two cores. So MS75, so the shallowest core in red, and in blue the deepest core, where we have this correlation coefficient, which represents the closer to one is the more reliable to reconstruct bottom current velocity. And we can see that, for example, the MS72, so in blue, which was the deepest core, was more capable, more influenced by bottom current at the origin. But then where we applied this 9-point correlation by Mackey Van Andrew, we could identify exactly which part, which sample, as we sampled every 5 centimeters in every piston course, which samples have been really rewired by bottom currents and which one has been rewired by a downslope process. And so we use for this the correlation and linear function of, as it was explained in the paper, which is a 9-point correlation. So here's to give you an example of correlation, how it's used, like we use the 4 samples before and after the one. And it's to return as a correlation coefficient of 9 cell ranges to determine the relationship between the sortable cell mean size and the abundance.
2 minutes.
So 2 minutes. Okay, it's always finished. And we do the same for the Linus function, which is a statistic for the scatter plot, the error in the slope. And so this is to represent where we have in the course reworked by bottom currents and the one reworked by downslope. And thanks to this, we were able to increase this correlation coefficient of the two cores, and so had a better constraint also which area we could use to reconstruct bottom current. So this is an example. On the right, we can see this on this graph the mean size and identified versus age of our two cores, and we compare these two cores with two cores analyzed by Tucan and Al 2012 to compare the different changes in oceanographic circulation in the Central Mediterranean Sea. And on the left, it's all the data for each course versus age and all the different proxies we used to identify the different processes. So I'm gonna try to skip this because it's running out of time. And but I'm gonna explain to you in the conclusion that what we observed during the post-last glacial maximum and the first phase of sea level rise, we saw that very typical sedimentary facies that we have lateral traction transport and similar structures proving the concurrent. So we have the presence of both along and downstream processes active at the same time. We have fluctuation, very high fluctuation in the bottom currents in the Stretto of Sicilia, in both cores, but this seems to indicate relatively changes not to climate change, but more affiliated to sea level rise and sea level passes. And the different emplacement of the massimo deposit, which were around 17 kiloyears or so, seems to be related to really high sedimentation rate changes before the failure. So that would be it. I would have loved to tell you a bit more about the different changes in practice, but time is short. Thank you very much.
Thank you, Dr. Very interesting, your research. Abbiamo tempo per questa famosa domanda di Luca Tugdual e poi magari chiudiamo.
Volevo sapere, visto che l'area diciamo è abbastanza sismicamente attiva, se avete pensato, se avete cercato di correlare tutti quei fenomeni franosi a possibili strutture sismogeniche. Lì c'è la falda di Gela lì vicino, quindi mi viene da pensare che sì, l'aspetto ovviamente delle correnti e dei sea level changes è fondamentale, ma c'è tutto l'aspetto della sismicità, se l'avete preso in considerazione.
Sì, no, certo, la sismica l'abbiamo considerata, ma è più per il nord di Gela, perché siamo un po' lontano dalla zona sismica, veramente, per considerare questo, per esempio, per questo frane, perché abbiamo più considerato le correnti e altri processi che non solo la sismica, perché la sismica, l'attenuazione sismica è un po' lontano per avere sufficientemente di potenza, penso, per avere una frana.
In realtà la parte, diciamo, la regione più sismica, più vicina, è più che la falda di Gela, che è ferma da un bel po', in realtà, sì, fa il sistema di Scicli probabilmente, e dall'altro lato la zona del Belice. Però penso che dove ha fatto vedere le sue cose puntuali siamo un po' lontani, insomma, rispetto a... no?
Beh, questo per noi, che abbiamo... Beh, per esempio, sì, abbiamo pubblicato questo con Zamboni su questo frane e un'altra frane al nord di una delle Twin Slide, un paper sulle tsunami potential di una frane della Twin Slide e questa frane di SGBS. So Zamboni et al 2021. So, e che abbiamo pensato che per la frane al nord era più relato alla sismica, ma che al sud dobbiamo considerare uno tra preconditioning factor o triggering factor.